Everyone, in this lesson we will be discussing the laws of logarithms and also finding the domain and range of log functions. First of all, let's recall our ideas from our previous lessons. It says that if x and y are positive real numbers, then we can develop certain laws. The first law is the product law, and that says log base a of x times y is equal to log base a of x plus log base a of y. That simply means the log of a product is equal to the sum of the logs of the individual arguments. For common logs, we write that as log of xy is equal to log of x plus log of y. And for natural logs, we write it as ln of xy is equal to ln of x plus ln of y. The second law we'll talk about is the quotient law, and that is where you divide the items in the arguments, or the elements in the argument. So log base a of x over y is equal to log base a of x, which was a numerator in the argument, original argument, minus log base a of y, which was the denominator. That means that if you have a log of a quotient, then you subtract the log of the denominator from the log of the numerator in the argument of the previous quotient. In common logs, it's read as log of x over y is equal to log of x minus log of y. And in natural logarithms, ln of should be x over y is equal to ln of x minus ln of y. Then there's the power property. Log base a of x raised to the k is equal to k log base a of x. That means that if you have a power in the argument, this is equivalent to taking this power and switching it in front of the log. And we developed the arguments for this in a previous lesson. In common logs, this log of x to the k is equal to k times log of x. And in natural logs, this ln of x to the k is equal to k times ln of x. Now warning, note that log base a of x plus y is not equal to log base a of x plus log base a of y, and log base a of x minus y is not equal to log base a of x minus log base a of y. Let's look at an example of how we can apply these laws. For example, expressed in terms of logarithms of x, y, and z, or w, log base 4 of x, z. Remember our product law that says that log base a of x times y was equal to log base a of x plus log base a of y. This will become log base 4 of x times z will be equal to log base 4 of x plus log base 4 of z. B, log base 4 of y over x. This is from your quotient law. And remember, a quotient law says that if we're taking the log of the quotient, that's going to be the log of the numerator subtract the log of the denominator. So in this case, log base 4 of y over x equals log base 4 of y subtract log base 4 of x. Finally, part C, log base 4 of the cube root of z. This is a power but in radical form, so we want to rewrite it in exponent form. So we write it as log base 4 of z to the 1/3. And then using our power rule, or power law, we bring this 1/3 to the front, so it becomes 1/3 times log base 4 of z, and that is our answer. Let us look at another example of applying our laws of logarithms. Here we have log base 4 of x to the 8th minus over times w over z to the second, y to the second times z to the fourth. We know right here that this is a quotient, so we're going to apply law 2 first. Law 2 is a quotient law, so this becomes log base 4 of x to the 8th times w, subtract log base, was an a, log base a of z squared times, that's y squared times z to the fourth power. Now let us apply law 1 to both of these because they're now products. You're looking at products, so that's going to be log base a of x to the 8th plus log base a of w minus, I want to use a parentheses right here because we're going to make this another product, and then we're going to be adding them if we expand it out. So that's log base a of y squared plus log base a of z to the fourth power. We continue working this down. This gives us log base a of x to the 8th, but we can apply the third property here, which is your exponent or power property. Bring this 8 to the front, so that's 8 times log base a of x plus log base a of w minus, we can bring this 2 over again, so that's 2 log base a of y, and then this minus is distributed to this plus, so that's a minus, and then applying property 3, this 4 comes over, so it becomes 4 log base a of z, and we're done. Okay, so we're done right there. Let us move on to another example. In this example, we have ln of radical x to the 5th power, ln of the radical x to the 5th power over y squared z. Now, because we have a radical here, we want to rewrite it as a power or an exponent. So we have ln x 5th power y to the 2nd power z, and that will all be raised to the 1/2. So all of that is raised to the 1/2. Okay? Now, we can distribute this 1/2 through, so that becomes ln x to the 5/2 over y to the 2/2, but 2 over 2 is just 1, so we can just write that as y, and then z to the 1/2. Right, so write z to the 1/2. Now we have this only as a quotient, so we take the ln of x to the 5/2, subtract ln of y times z to the 1/2. Next, we apply property 3 to this first part, so this becomes 5 over 2 ln of x minus, let's use a parenthesis because now this product will be expanded out to become a sum. That's ln of y plus ln of z to the 1/2. And the next step, we bring down this 5 over 2 ln of x minus ln of y. This minus distributes through the parentheses. Minus plus becomes minus. Apply the third property here, or the third rule, to ln z to the 1/2. It becomes 1/2 ln of z. And then we are done right there. That's our final answer. We continue working through some other examples, applying these properties of logarithms. We have 1/2 log base a x squared minus 1 minus log base a y minus 4 log base a of z. So 1/2 log base a of x squared minus 1 minus log base a of y minus 4 log base a of z. And in this problem, we are going in the opposite direction because now we are writing this expanded version as one logarithm. First of all, applying the third law, we write this first part as log base a of x squared minus 1 to the 1/2. And then minus log base a y. There's not much we can do right here just yet. Then this third part, we subtract log base a of z to the 4th power. Right? Continuing on, we're going to write this as log base a of the square root of x squared minus 1 minus log base a of y minus log base a of z to the 4th. Right? Now we're going to apply another law of logs, right? Apply another law of logs to bring these two first parts together and write it as a single log. So that's log base a of radical x squared minus 1. And because it was a subtraction here, means that we're going to divide the arguments. That'd be over y. Then subtract log base a of z to the 4th. Then finally, we will bring these two parts together. And so log base a of radical x squared minus 1 over y. And then we're doing another division here. So that is times z to the 4th. And that is our final answer. Okay? Now, the next problem is